Greetings, Internet! Welcome to the blueprint discussion of my portfolio level. If you're watching this video, you've hopefully seen the gameplay videos, but if not, the Cliff Notes version is that you're in a spaceship engine room and you need to repair 3 broken components and restart the reactor in order to survive. This video is going to be a detailed discussion about how I designed the level. I chose to use various methods of implementing mechanics in this level in order to showcase my knowledge of the Unreal Editor. As you'll see, I use traditional actor blueprints, the level blueprint, blueprint interfaces, dispatch events, and more. I even used the sequencer to trigger an animated level mechanic. I also made copious use of comments in my blueprints to keep fellow developers informed. I hope you enjoy. Let's dive in. Right off the bat, the player is displayed with some information about the level and their ability to quit or restart. If you follow along with the comments, you can see this was handled with a widget blueprint that is called Inside the Level Blueprint. At the beginning of play, the widget is added to the player's viewport for a brief period of time before being removed. I also handled the quit and restart level functionality inside the level blueprint by simply creating a key binding and calling the respective quit or restart level node. The countdown timer is its own widget that is receiving information from the player character. Inside the third-person character blueprint, I'm using the event tick to modify the seconds and minutes variables. These variables allow me to set the timer to whatever I like. A delay of 1 second is used to keep the timer functioning in real time and not based on the processor's tick rate, which would result in an extremely fast or slow timer depending on how your processor is functioning. Every second and seconds variable is being decremented by 1, and every time the seconds reach 0, a minute is subtracted and the seconds are reset to 60. If the timer reaches 0, the game is paused and a losing screen is displayed that allows the player to click a button to restart the level. This console mechanic is an unnecessary interaction for the player to complete the level, but will give them some helpful information if they are stuck or confused. At the beginning of play, this console also plays the alarm sound that the player hears. It is a simple instructional widget that is triggered by the player overlapping a box collision. When the player leaves the box, the widget is removed and the player no longer sees the information on screen. This console also displays a miniature of the broken engine components. They are set to visible when the player overlaps the trigger volume and not visible upon leaving the volume. This interactable laser is another unnecessary interaction, and the first item we're examining that makes use of the interface I set up. Any mechanic in this level that allows the player to press the E key to interact with it makes use of this interface to handle the blueprint communication. This is handled in the third-person character blueprint. When the player uses the input action to interact, or the E key, the third-person blueprint checks everything that the player is overlapping, checks if that object is implementing the interface, and if it is, calls the interface's interact function. When the player overlaps the box trigger, they are given a prompt asking them if they want to fire the lasers. If the player presses the E key, a sound effect is played, and the 2 Niagara particle systems are activated simultaneously. This is handled by the blueprint interface. When it has been called, it will activate a custom event in the laser console blueprint, which activates the lasers. The fire laser event also calls a custom laser counter dispatch event that tracks data for the player at the end of the level. This interactable is also not required to complete the level. It functions nearly identically to the laser consoles. When the player overlaps the box, they are given a prompt asking if they want to activate the energy beams. If they choose to interact, a sound effect and Niagara particle effect will play. This blueprint also uses a custom dispatch event to store data for the player at the end of the level. This is a simple elevator mechanic that I implemented to help the player traverse the map. The player has other ways around the level, so it is not a required interaction. In order to implement this, I decided to use the sequencer instead of a blueprint. The sequencer is a linear editor that has been compared to video editing software, and while you can add a camera to it for exporting video, it can also be used to animate anything inside a scene. The items attached to the sequence use keyframes to govern where they should be on the timeline. If I slowly scrub through the timeline, you can see the objects animating in level. In order to have this animation play, it can be called inside the level blueprint. If the player overlaps a box trigger, the level blueprint gets the sequence and plays it. I also added a sound effect here in the level blueprint to give the player more feedback. This security door also uses a box trigger to display information to the player. If the player is close enough to the door, it will tell the player how to open it. The interaction is handled through our Interact Blueprint interface. Once the player has interacted, a custom door open event starts. This makes use of a timeline. Timelines are powerful functions that allow the player to have an action play out over a set amount of time. This timeline is 2.5 seconds long and sets the door component's relative location over that time period. At the beginning of the timeline, it gets the door's starting position and adds 186 to the Y location value in the level. This movement over the course of time in the timeline is what gives the door its slow sliding motion from one position to another. The blueprint also plays an electronic sound effect that is supposed to sound like a security door slowly opening. This fixable engine component is the main objective of the level and my personal favorite piece. As you can see here, if the player approaches the console, they will get a prompt telling them to press E to repair the console. This was handled by a box overlap the same way that the other interactables are. At the beginning of play, the console sets damaged bool to true. Then it sets the visibility of various components to true or false respectively in order for the component to appear broken. If I toggle the visibility of the different meshes, you can see that both the broken version and the fixed version exist within this blueprint. This is what is being set at begin play, as well as the fire visuals and sound effects. When the player presses E, the blueprint checks if the engine is still damaged, and if it is, the damaged bool is set to false. This is to ensure that a broken engine component can only be repaired once. Then, a dispatch event is sent to the player to have the player enter an animation state. In the player character blueprint, when the dispatch event is heard, the player's input is disabled to freeze them in place while the animation plays. Then, a 10-second custom animation montage is played. A 10-second delay is implemented so that when the player input is restored, the animation has completed. This animation is a custom animation that I created by blending two of the pre-made character animations together. Back in the engine blueprint, a delay is also used to give the animation time to play out before the visibility of the various static meshes and sound effects are reversed in order to give the appearance of a repaired engine component. Finally, a dispatch event called Repair Complete is sent to the final objective so that it can keep track of how many components have been repaired. Once all three broken components are repaired, the final console becomes active. This is accomplished using a bool called Repairs Complete that is set to false at the beginning of play along with a number of repairs completed variable which is set to a default of 0. Then we're casting to the Fixable Engine blueprints by using the getActorOfClass node and binding to the Repair Complete dispatch event from that blueprint. If an engine component is repaired, the dispatch event is heard and the number of repairs completed variable is incremented by 1. On update or event tick, we are checking if the number of repairs completed has reached 3. Once 3 components have been repaired, this branch can fire, which will set the repairs completed bool to true. Once the repairs completed bool is true, the player will be given a prompt to start the reactor when they are near the console. If the player interacts, the blueprint checks one final time that the repairs are complete, then fires an ignition dispatcher dispatch event. This event is being listened for by a blueprint that governs some Niagara particle systems that are meant to represent the reactor and ship's engines. After the reactor has been started, the player is displayed a final HUD widget that informs them they have won, as well as displays information about their experience. This information has been collected and stored via the dispatch events in the various level mechanic blueprints. After the engine has been activated and the widget displayed, a timer of 12 seconds will begin, at the end of which the game will automatically quit. Well, that's the nuts and bolts of my portfolio level. I hope that this blueprint breakdown was informative and enjoyable for you. I hope you have a great day.